Hey, what's up, everyone, and welcome to Daily Code Buffer. This is a new series that is scalable thinking, system design, where we are learning system design in terms of two ways to be prepared for your interviews as well and to be prepared for your job as well, where you can build the scalable system in your job profile. Now, in this video, we are talking about load balancers. So, we will understand what is load balancer, the importance of load balancer, and the different ways of load balancer, and we'll also see how we can implement a load balancer, and we'll also see what is the core functional logic behind a load balancer. There are by default a lot of load balancers available, so we can directly use it, but we should be aware about how those things work. So to start with, what is a load balancer? So if we see an application here, you can see that this is the current year application, and here you can see that we have a client and we have a servers available here. Okay, so if your client is directly connecting with your server, right, if your client is directly interacting with your server, and if that server goes down, then your client will not be able to connect to that server. So in that case, your client will be directly impacted and your server is not responding, so it's a direct impact to your application. So to make sure that you do not have that impact, what we do is we have a multiple servers. We do a horizontal scaling where multiple servers are added. Now to manage those multiple servers, to make sure that client requests are going to all these servers with a distributed manner, we add a load balancer in between. So this load balancer's job is to identify all the requests coming from a client, and based on the different strategies defined within a load balancer, it sends the traffic to the respective server. So if there are 10 requests coming in from the 10 different servers, based on the different strategy, it will send the request to S1, S2 servers. And if we add the different servers also, it will be able to manage all those servers within our system. Now, why it is important to have a load balancer within our system? There are 4 different reasons to have a load balancer. The first one is the scalability. As we already talked about how we can scale our system. If I have a million users coming in within the day, and suppose consider if I have a flash sale coming on for my website, then I am expecting around 2 to 3 million more users on a flash day sale. So to handle all those such traffics, what I need to do is I need to horizontally scale my system. I need to add multiple servers like S3, S4 and all. Okay, so now you can see that I'm adding a lot of different servers. My system should be able to handle all those different servers, and load balancer will help in that to distribute the traffic through all those different servers. So scalability is an important aspect when we are considering for a load balancer. Next is the fault tolerance. So suppose if we have 4 servers available and one of the servers goes down, suppose S1 goes down, in that case your S1 server is faulty server. So your load balancer should understand that, okay, S1 is a faulty server, let's not send the traffic to the S1 server and let's send the traffic to the rest of the servers available. So that's the job of a load balancer, which makes it more important to have a load balancer within the system which handles such kind of scenarios for us to maintain a fault tolerant system. So what it will do is it will also try to add a new server available if there is any fault in the current servers. So suppose you are saying that I need to always maintain 4 servers available. So what it will do is it will identify that, okay, S1 server is faulty. Let's add a new server because I need 4 servers available. So it will add a new server S5 available and make sure that S1 server is not available and the traffic is not served there. It can also define such a way that it will allow S1 server to recover itself and then it will send the traffic to the S1 server. So there are different applications how you want to handle it. So that's the fault tolerant capabilities of a load balancer which will help our application to scale appropriately. The next is the performance aspect. Now, as we already talked about the scalability, the performance aspect comes into picture where your response time or your throughput gets affected because there are a lot of traffics coming into one single server. So suppose your capability of a server 1 is 100k request, okay, and there are 200k requests coming into the server, and if there is no load balancer, all the traffic will go to server 1. Now if you have placed a load balancer in between, load balancer will identify that, okay, there are 200 k requests coming in, and I have to divide all those requests distributedly evenly so my servers does not get loaded up and the response time or throughput will not be affected. So this will adversely increase the performance of your application as well, which will decrease the response time or a throughput for your application. And as you have multiple servers available, your scalability and your performance aspect is also covered. The next is a maintenance activity. So maintaining your application when you have a load balancer is really easy. So suppose if you have to maintain your application or you want to publish your latest code available, then rather than just changing the one server available within your system, what you can do is you can have a canary deployment where you can just change few servers available. Suppose I have 4 servers available, I can add my code or I can deploy my code to couple of servers available, and once we have deployed to these servers, we will give a soak time to make sure that the system are stable, and then we will add our changes to the rest of the servers available. So it's a canary deployment that we can follow to make sure that it's very easy to maintain the application whenever we want to publish the different changes as well. So these are the different aspects which tells us to use a load balancer within a system and giving the advantages to us. Now, as we have understood what is load balancer, there are different categories of load balancers available we can use within our application. So the first is either a static load balancer or a dynamic load balancer. So what is a static load balancer? Static load balancer defines a very static nature where whatever the number of requests comes in, those are equally divided into the different servers. So the most common static load balancer is a round robin one. Okay, we'll come to that as well, like what are the different types of load balancing algorithm. But if you're talking about static load balancer, round robin comes into picture, where what it will do is it will divide the load equally to all the servers available. It will not account for any other information. It's simply whatever the request comes, divide into the number of servers available, and it will serve the traffic for us. Now, on the other hand, dynamic load balancer takes into consideration of the resource limits, CPU, memory, and all those kinds of information. And based on that information, it identifies which particular request should go to which particular traffic. So in that category as well, there are multiple algorithms available to identify this dynamic load balancing, to make sure that based on the resources that you have, based on the traffic that you have, based on the memory you have, your request traversal to the different server has been identified and your application is served with the request. The next is the layer 4 and layer 7 load balancing. Now this layer 7 and layer 4 describes the OSI layer. So layer 4 is your IP layer, that is your internet protocol TCP UDP. So layer 4 will be defined based on the TCP UDP protocol for your application. So it will be much faster than the other types of load balancer because it is identified based on the TCP UDP connections available. The next is the layer 7 protocol. So layer 7 load balancing defines based on your application, that is your HTTP and HTTPS bindings. So how the requests are being handled for your applications, based on that you can define your level 7 load balancing. So these are the different categories of load balancing. Let's understand more about the different algorithms of the load balancing. Now, different load balancing algorithms. Here you can see that I have added 6 type of load balancing algorithms. There are many more as well, but we'll talk through these 6 because these are widely used within the industry. Now the first one is the round robin algorithm. So what round robin algorithm does is, round robin is already we suggested that it's a static load balancing algorithm. So what it will do is, whatever the request that we have, that request will divide by the number of servers and it will serve the traffic. So suppose I'm having 5 servers available and I'm having 10 requests. So what it will do is, first request it will send to first server, second to second, third to third, fourth to fourth, fifth to fifth, and sixth to again one. So it will sequentially send the request to all the servers in a round robin fashion and it will serve the traffic. It will not consider about the resource limit, CPU limit, or any other information. So that's the simplest form of load balancing algorithm and it is widely used within the industry. Now there is also a variation in the round robin algorithm, that is a weighted round robin algorithm. So in weighted round robin algorithm, what is the advantage is that it will add a weight to the server. Now by default, round robin algorithm is mainly used in the homogeneous system, where all the servers have a similar kind of capacity or a similar kind of application. Okay, so in that cases round robin is used. But if you have different sets of server available and different sets of application available, and one of the application needs more memory, one of the application needs lesser memory to serve the traffic, in that cases you can use the weighted round robin. So in weighted round robin, what you do is you add a weight to a server. Suppose server 1 is there, weight is 2, server 2 is there, weight is 1. That means that server 2 can handle half of the traffic than server 1. So if I'm talking about the request, then server 1 will be able to handle twice the request as server 2. So that's how you define the weight, and based on the weight, request will be sent to the different servers available. So it's a modification on the existing round robin algorithm, and this is mainly used in the heterogeneous servers. The next is the least connections. So this means that out of the servers S1, S2, S3, the number of server, okay, and out of those servers, the server having the least amount of connections. So suppose server 1 will have 2 connections, server 2 have 1 connection, and server 3 have 3 connection. Then while sending the traffic, it will select the server 2 because server 2 has the least connections available. So that's how the least connection algorithm defines that out of all the servers available, which server has the least traffic and least connections available, and based on that it will serve the request to that particular server. Now to least connections as well, there is a modification to it just similar to round robin, that is a weighted least connections. So in that case also we give a weight to the connections available. There will be some servers available which can handle more traffic than different types of servers. So in that case we added a weight to it, and based on that weight the least connection will be identified and the request will be served. So in this case we will define that, okay, for weighted least connections, if I have server 1, server 2 and server 3, weight of server 1 is 1, weight of server 2 is 2, weight of server 3 is 3, and the connections are also defined such a way that, okay, connection is 1, 2 and 3. Okay, so now based on the weight and based on the connections available, it will identify that which server the request should go through. Then the next is least response time. Now this algorithm identifies the response time of a given server. So suppose if I have multiple servers available and the server giving the response in the lowest amount of time, that particular server will be selected for serving your traffic. So that's a simple, so you can see that it's very simple, where whatever the servers we have, and out of those servers, who is the least busy, who is able to serve your traffic very quickly, those server will get the request for you to serve the traffic for your application. The next is the IP hash algorithm. Now IP hash algorithm will use the IP address of the client, and based on that IP address it will hash the data, it will hash the IP address, and based on this hashing it will send the request to the servers available. So this is similar to what we have understood in the hashing algorithms and the consistent hashing, where it will hash the number of servers available. So suppose I have 5 servers available, and what it will do is, based on the hashing algorithm, for the IP address we will get some hash value, and that hash value is doing modulo operation on the number of servers, and that will give me one of the servers available, and the request will be served by that traffic. Now this kind of algorithm is used mainly in sticky sessions. So whenever you have a requirement of a sticky session, at that time this kind of algorithm is being used. So mainly if you want to have WebSocket connections established or a database connection established, at that time IP hash algorithm is being used, and more advanced algorithm would be consistent hashing algorithm. So these are the different types of load balancing algorithm available. What I have done is I have added a base code or a reference code of all the such kind of algorithms in the repo. I will share that as well with you so you can go through it as well. This code is just to have a reference for you that how internally this kind of algorithm will work. There are already different sets of load balancers available. You can directly use those load balancers and you can use it. Now one more thing within the load balancer comes is the hardware load balancer and a software load balancer. Now, software load balancer is the application that runs on your server to route your traffics. That is like Nginx, HA proxy, and all such kind of applications which help you to route your traffic, which is a load balancer as an application. Now, the hardware load balancers are load balancers defined by the hardware. So there are multiple companies that gives the load balancer as a hardware. So F5 Networks is there. I'm not sure about the others. I think F5 Network is something that I'm aware of. So those kind of companies give you a hardware load balancer which will serve your traffic for you. Now let's talk about the advanced strategies as well. So within the advanced strategies for load balancing, one of the thing is consistent hashing. We have already talked about consistent hashing in a separate video. So if you want to learn more about consistent hashing, then you can go through that video to learn more about it. Now, consistent hashing will do the same thing. What it will do is it will make sure that whatever the number of servers that you have, those number of servers will have the equivalent number of traffic to serve through based on the request. So what it will do is it will create a ring-like structure, and on that ring-like structure, you will have a different servers available, and all the requests will lie on the different parts of the ring, and all the objects, all the requests will be served by the next available server available. Okay, so all this requests will be handled by this server, all this requests will be handled by this server, all this requests will be handled by this server. So that's how the consistent hashing algorithm will work, and it is more advanced algorithm compared to all the algorithms that we have used. Mainly this is used in database, socket connections, mainly whenever you have to have the application with very low latency and very consistent type of application. The next is the adaptive or auto scaling algorithms. Now in this type of algorithms, what it will make sure is it will take the input from all the different systems. So the CPU resource, the memory resource, your network resource, all those different types of application, different types of metrics will be identified, and based on that metrics and the auto scaling capabilities, your algorithm will define that how you have to serve the traffic. So it's very advanced kind of algorithm and a hybrid system as well, which is mainly used within the industry. So basically all those different algorithms that we have defined is not a one fit solution for all. You need to make sure that you use a combination of those or and some advanced topic or advanced system which helps you to identify the perfect algorithm to make sure that your all the requests are being handled for your system. It cannot be like for all your application only one type of algorithm can be used. For all your different services, you might have to use the different sets of algorithms as well. The one is geographical load balancers. So geographical load balancers are mainly used within the CDN or caching systems, where you need to define the nearest geolocation based on the client's request to serve the traffic. Okay, so these are the different advanced and hybrid topics of the load balancing algorithms. Now, what are the key considerations you should consider while using the different sets of load balancing techniques? The first one is health check and monitoring. So you need to make sure that you define proper health checks and monitoring for your application, because this health checks and monitoring will be used for your load balancers to identify what is the health of your system, how your system is been monitored, because some sets of algorithm requires this monitoring to be set up, right? So we need to consider that how our health checks are there and how we are monitoring our system. The next is the scalability and elasticity. So you need to make sure and define that how you want your application to scale and how you want your application to dynamically scale up and scale down your system. Based on that, your load balancer can serve the traffic. If you have not defined that your application cannot scale horizontally, but you have just defined 3 servers, then load balancer has to work accordingly. Then the cost and the complexity trade-off. So while defining a load balancer, you need to make sure that you define the cost optimization as well, because all the different sets of algorithms which are used may not fit all the solutions. Suppose if you are just having an homogeneous system, and at that time if you are using a consistent hashing algorithm, that might not be the best suit for you. You can be good off with the round robin algorithm as well. So you need to consider all those scenarios as well, how your system is, how your different applications are interacting with each other. Based on that, you need to define your algorithms as well, because this also adds a cost to it. Suppose if you are using an algorithm where your monitoring has been highly used, then monitoring is not a cheap thing. It's a lot of cost involved in the monitoring of the application as well. So it will increase the cost as well. So you need to make sure that whatever the complexity that you are choosing for within your algorithms, you need to have the sets of trade-offs also defined, that okay, while using this algorithm you are trading off with the cost. If you're using this, you are trading off with the eventual consistency or scalability issues or whatever it is. Okay, and then the security considerations as well. So mainly whenever you are using an algorithm, what will happen is you will be, suppose if you talk about the DDoS attack itself, right? So if you do not have the load balancer in place, what will happen is if you have 1000 requests coming into your server but your capacity is only 200 requests, then your server will not be able to handle that request and your server will crash. So that's the DDoS attacks on your server. But when you have a load balancer in between, and when you define that okay, I can handle only this many requests, if more requests are coming in, those requests has to wait if the server is not available. If the server is available, you can route those traffic to the other server available. So this consideration will help you to also have the security considerations within your system. So these are the key things that you need to make sure that you define when you are working with the load balancers. So what I will do is I will just walk you through the code as well. So what I have done is I have the different, you can see that I have defined the load balancer package within the system design repository, and here you can see that different sets of load balancers are available. You can just go through this. This is a very simple implementation of the different algorithms. You just need to identify how that works. Actual implementation will vary based on the different load balancer providers. So if we talk about the simple round robin load balancer, so here you can see that it's a simple round robin load balancer. So what it is doing is it is having an atomic integer to make sure that it is a threads of application. So what it's doing, it's simply doing the get server for the request it's coming in. Okay, so whatever the request comes, it needs to identify the server and send the server back. What it will do is it will take the all healthy servers from the list of servers available, and based on that it will check that okay, if the servers are not there, if it's empty, that means no server is available to handle the request, you need to send null. If not, what it will do is it will increment the value and it will do the modulo operation on the servers available, and based on that it will send the next server available. So it is doing a round robin. So if you have 5 servers, it will send the request to each of the servers available and it will again repeat for all. That's how the simple round robin works. And if you go to weighted round robin, you can see that for everything we have added a server weight to it. It's a very simple thing, but just a weight is added, and based on that weight, you can see that based on that weight it will identify the server. So you can go through the code. It's very simple to understand. The next is the IP hash. You can see that the IP hash is nothing but it will hash the client IP, and based on the client IP hashed value, it will identify the which server it should go through and it will send the index of that server. Okay, so this is all I wanted to share about the load balancers. These are very critical part of your distributed system. So you need to make sure that you understand load balancers. Everyone will know that there is a load balancer in between, and whenever you are going with a system design interview, you will define that okay, this is the load balancer that you're going to use, but which algorithm to use, when to use which algorithm, that you need to understand, and that will help you to make sure that whatever the distributed system that you are designing, that can serve the required traffic based on this type of load balancers. So that's what I wanted to share today with the load balancing algorithms. Make sure that you go through this repository as well to understand how the different sets of algorithm works. And if you have any doubts regarding any of the things covered, then do let me know in the comment section below. Give us a like on this video and share with your friends and colleagues who wants to learn about the load balancers and system design. So that's been it in this video. I will see you in the next video. Till then, happy coding. Bye bye.